Hello everyone. Today we will see how to determine the iodine value for a particular oil or fats. So this particular analysis is an example of iodometry. A solution of iodine is yellow or brown in color. When this is added to a solution to be tested, however, any chemical groups, usually in this test C double bond C double bonds that react with iodine effectively reduce the strength or magnitude of the color because by taking the iodine out of the solution. Thus, the amount of the iodine required to make a solution retain the characteristics yellow or brown color can effectively be used to determine the amount of iodine sensitive groups present in the solution. A known weight of oil is treated with ICI solution in carbon tetrachloride or chloroform, and the amount of ICI absorbed is determined. In this process, the chemical reaction associated with this method or analysis involves formation of the diiodoalkane. For example, when an unsaturated alkene R bond CH double bond CH bond R dash treated with iodine, it will give saturated alkane, that is R bond CHI bond CHI bond R dash, where R and R dash different alkyl groups. So after completion of the reaction, potassium iodide solution is added, which is oxidized to iodine by unreacted ICI. The liberated iodine is treated with standard sodium thiosulfate solution using a starch solution as an indicator. So for this titration method requires some chemicals as well as some apparatus. So first we will see that apparatus. So for this titration, whatever apparatus is required, that should be clean as well as perfectly dry. Otherwise, whatever result we will get it, that result may be containing some error. We won't get that exact result or accurate result. That's why we have to, whatever apparatus is used for this titration purpose, that should be cleaned, free from any impurities, like the apparatus like conical flask 250 ml, burette 50 ml, and pipette 25 ml pipette is required for this titration. And that chemical also required for this titration, like glacial acetic acid, carbon tetrachloride, iodine trichloride, potassium iodide, sodium thiosulfate, and starch solution as an indicator. So for this titration, we have to prepare some solution. Before starting the titration, so the sodium thiosulfate solution should be prepared. It can be prepared by dissolving 24.8 gram of sodium thiosulfate in water in a 1 liter volumetric flask. Then potassium iodide solution. It can be prepared by dissolving 100 gram of potassium iodide in 1 liter water. Then ICI solution or which solution. This can be prepared by dissolving 9 gram of iodine trichloride in a mixture of 700 ml glacial acetic acid. That should be pure. It cannot be containing any moisture, and 300 ml of carbon tetrachloride. Now we'll see that procedure. Dissolve the appropriate quantity of oil in a 250 ml conical flask in 15 ml carbon tetrachloride. Add 25 ml of which solution from the burette to the mixture. Close the flask, shake gently, and allow it to stand in dark at about 20 degrees centigrade. For oil having iodine value below 150, leave the flask in dark for 1 hour. For those with iodine value above 150, the flux for 2 hours. After that, add 25 ml potassium iodide solution and 150 ml of water. Then whole solution we have to titrate it with liberated iodine with standard sodium thiosulfate solution using starch solution as an indicator. Continue the titration until the blue color just disappear. Record the value of sodium thiosulfate used in observation table. Carry out the experiment against to get at least two correspondent readings. Carry out a blank test without oil under the same condition. Then record the volume of sodium thiosulfate used in observation table.